Hi guys, I just thought I'd go over the Chapter 6 AP style questions that I made up for you. Now, after looking over your assignments and marking, I'll just run through the answers here. 1C, 2B, 3A. These were generally well done, so I won't spend time. If you need, email me to ask. Go along with yours and mark it as well. Okay, 4C, 5A. Of course, you can just pause and take a look at what I have written down and email me if you need anything extra, right? Okay, 6. Now you can see I edited the version you have, so I've typed over. But anyway, 6 has 3 possible answers. C. How did I do that? Take a look here. I applied the fundamental theorem here. G is an antiderivative, which means that if you go from 2 to x for f of x dx, you got g of x minus g of 2, and I just subbed in from there. And that's solved. This one I used long division. It's tougher than normal. I don't know that you'll have anything like that on your AP test, which I hope we're all ready for in May. Home test. I forget the date off the top of my head. It's 8C. Okay. 4, page 4. This one, a lot of you did get wrong, and here's why. The answer is C. If we read carefully, you all use this function in liters per hour, where T is measured in hours since 2 p.m. 2 p.m. would be considered hour 0. How many liters of water are pumped between the 4-hour period from 3, or hour T equals 1, to 7, T equals 5. So this is what you would have entered into your calculator with the S function, dt. Okay. The other ones, okay, fairly well done here. 10B, 11C. Think about this one. Ask me questions if you did get it wrong. If you're, well, just think about it. 12 is A. 13 is A. Now, here's the long questions. I'll stop and make a second video here. No, I won't. Okay. So this is a function where I've given you graph data, or a chart of data. And we'll call this function R, and I used Regina for R. Anyways, 0 to time 8. Use the data to approximate the derivative at 4. And units of measure are needed. So 4, you can tell here, is in between 3 and 5. So you just did the slope calculation because you know a derivative. Okay, anyways. And that's measured in centimeters per day. Just get that from here. Okay. So rate. B. Approximate the value of the integral from 0 to 8 using a left Riemann sum. By the way, don't use the LRAM, RRAM kind of notation. Say left Riemann sum, right Riemann sum. Okay, when you were writing out answers. Anyways, you just do the area of the rectangular strips. That was well done, 511. It's an underestimate. Is this approximation greater than or less than the actual value? It's an underestimate. This is less than the integral from 0 to 8 RT dt, since it is a left Riemann sum on an increasing function. You need that. By the way, you guys, when you're doing your test, you don't have to simplify your arithmetic. You can come up with 511, but you know what? It's time consuming and you may make an arithmetic mistake. If you have it just down to arithmetic, like this statement here, leave it on your test. I think it's May 11th, but don't quote me on it. Look it up again. Okay, now I introduce a second function for Saskatoon. Same kind of barrel as in Regina. However, the water in Saskatoon is removed frequently, so it's going to go up and down. And here's the model. We have an actual equation between 0 and 8 days. So the question is, find the average depth of water in Saskatoon between 0 and 8 is this value greater or less than the average depth in Regina? So the average in Saskatoon is, well, 1 over 8, time span of 8, the integral from 0 to 8. And this is a calculator question, so there you go. You won't have calculator questions on your exam, by the way. It's going to be short. You can have your calculator, but it really won't help you. Anyway, so use your calculator to come up with that. Same skills, though. You got to understand these. Now, the other marks justify your answer. The approximate average of Regina on 0 to 8 is an eighth of 511, which you got earlier, 63.875 centimeters. Okay, compared to 25, well, the average value of Saskatoon between 0 and 8 is less than the average value of the Regina function on 0, 8. That's where we get that from. D, is the depth of the water in Saskatoon's barrel increasing or decreasing at time t equals 4? Give a reason. Well, you need to show it. S prime at 4 is equal to negative 12. And the number, you write it down. But the reason is the depth of the water is decreasing since S prime at 4 is less than 0. Okay? And that's all you need for a reason. Page 7, sorry. And question 15. Okay, I give you two functions. This is a calculator one. But if it wasn't, you just have simpler functions and you do the same thing, so it's worth doing. When is the particle m increasing? Give a reason. The velocity of m is increasing on this interval since the acceleration is greater than 0 on that interval. So, there you go, the acceleration function. Find the position of particle m at t equals 2. Well, the position function is, or the position is given by the integral from 0 to 2. And you know your starting position. You basically have to use the integral to add it. You could have started directly there. I usually set it up this way, knowing that the antiderivative is position 2 minus position at 0. And just let your calculator do the arithmetic. You can pause and take a look if you need to. Question C. Explain why there must be a time t at which the velocity of the particle n is negative 2. Well, the mean velocity on this interval is negative 2. And the mean value theorem guarantees at least one time t on 0 to 2 when the velocity is equal to negative 2. And why? You can use the mean velocity theorem since the function, the position function, is continuous, because it's differentiable, so you know this. Look up these little things and make mention of mean value theorem, etc., if necessary to justify answers. Now, D, at a time t equals 2, the velocity, just make sure it's in camera, is positive 1. Is n moving towards or away from m at time t equals 2? Well, the position, 0.128, and the velocity is positive, so it's moving to the right from a position of 0.128. The other particle, n, is at negative 1, and its velocity is also to the right, so it's moving to the right from x position negative 1. So I just think of it like this. I put the position here, m and n, negative 1, 0.128. They're both moving to the right, therefore, now this is just my thinking thing. You can write it down, but it's not your justification. To explain your reasoning, you need all this work. Therefore, n is moving towards m at t equals 2, since it's moving to the right. Okay. Page 8. 16. I guess when you guys printed it, some of you got extra, your pages kind of moved around, so it might not jive with what I have. Anyways, there's a very good possibility you could have a question like this with A, B, C, D, E kind of sections and testing you different ways. This one's without a calculator. F is the function given by the integral from negative 5 to x for this g graph. Find all the points where there's a critical point and classify. Well, first of all, you need to know the derivative of the f function is equal to just the g function. And so that means there's critical points wherever there's 0 on this g function, because that's the derivative, f prime. There, 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 -4, 1, and 3. That's where we get them from. And f as a local max at -1, or at, sorry, +1, since the derivative switches signs from positive to negative at 1. You see, positive values switching to negative values. Minimum, local minimum, at -4 and 3, since the derivative f prime, which is represented by this graph of g, switches signs from negative to positive at those values. That's your reasoning. Find the derivative, or no, not the derivative, f of 4. Well, f of 4 implies that you go from -5 to 4 for this g function in an integral. So -5 to 4 stops right here. So you just got to add up all these little areas. You can stop right here. The rest is just arithmetic. It's not hard to figure out. It's 1. But on the test, I'd advise you to just stop when it's just arithmetic. Less time, less chance of mistakes. 9. Part C. Pardon me. Hopefully this is the same one you had. The limit. X approaching 1. F of x negative x squared minus 3. Okay, use the picture to figure that out. Okay. So you figure out it's 2, and then sub in for the -1. Okay. D. Let h be this function. Or using g. Apply the quotient rule. Derivative of the top, bottom left alone, minus top left alone, derivative of the bottom, the whole bottom squared. Then substitute in all your values. Stop here. The rest is just arithmetic. However, if you worked it out, it's +1. Okay. Page 10, not a calculator question. So be prepared for something. All the calculator questions are good, actually. You just have simpler functions on a AP test. Is f continuous at 0? Remember, there's 3 things for continuity. So first you check, does it exist at 0? So you plug it in here. Yes, it does. Second thing, does the limit exist at 0? So the left gives you 2 and the right gives you 0. Then, therefore, the limit at 0, x approaching 0, f of x, does not exist. If that did exist, by the way, the third criteria to be continuous is that the function value, so f of 0, and the limit of x approaching 0, f of x, have to give you the same value. That would be a third test if you need to test for continuity. But this one doesn't, so you'd stop after the second test. Okay. B. Go back and review continuity. Anyways, 2. F prime of -2 and f prime of 2. Find those values. Well, f prime of x is equal to, well, for the top portion, -2x. This does not include 0. It's undefined at 0 because there's a discontinuity, as we proved there. And then 3e to the 3x for the second portion. Okay. So f prime of -2, use that one. F prime of 2, use this one. There you got your answers. Why does f prime of 0 not exist? I already mentioned this. F of x is not differentiable at x equals 0 since it's not continuous. Okay. Let g of x be the continuous function given by, and then here it is. Find g of 2. G of 2 is this -2 to 2 function. Remember, f has a discontinuity at 0, right? So that means you have to break this integral up into 2 chunks. And there's 2 separate equations. -2 to 0, 0 to 2. The rest is just simple calculations. The real trick is separating it into there. Once you get it just to arithmetic, stop. But if you worked it all the way out, it would be 1 plus 1/3 e to the 6. Okay? I will stop and leave that for you.